Hey everybody, this is Gregory from DAP University. So in this video, we're talking about writing Ethereum smart contracts with the Solidity programming language. And I'm picking back up in a series on Solidity, and we're talking about writing functions inside of smart contracts and what you can do with them. So be sure to subscribe to this channel if you haven't already, and click the like button down below. That really helps these videos get found so that more people can learn how to build blockchain technology. I'm going to go ahead and pick up where we left off in the last video. I'm going to use this, my contract that we built where we added a person struct to this mapping of people. So if you haven't seen that last video, go ahead and check that out. It's not necessary, but you can probably follow along with this video if you want to. What I'm going to do now is show you a little more about these modifiers like public and things like that. I think we talked about that in the first video, but I'm going to go just a little further. So what I can do is, show you another modifier, which is basically like internal. So that's different from public. Public is a function that can be called, on the public interface of the smart contract. You can see, the public functions listed here on the side. So I'll go ahead and create a private function, or an internal function, excuse me. I'll say function. We're just going to take this people count and wrap it in its own function to show you how that works. We'll say increment count. We'll just make this a function, and we can call it internal. That's a different modifier. We'll just take this people count, we'll paste it inside of here. All right, and we'll just say increment count. Call that function, and we'll run it. See the smart contract, we'll add the person. We'll say DAP University. And I'll click add person. And there we go. It incremented the count. You can see the people count has been changed. You can say Joe Blow. And the count's changed. So that's a way that you can, use other functions that are going to be internal. And we can see this increment count function isn't added to this list over here. It's not exposed to, things outside of the smart contract. External callers can't use it. So that's an example of, other, types of visibility of functions in Solidity. Let's talk about function modifiers. So we can add, more, words and terms to the end of this function to change how it behaves. And I'll show you an example. So we're going to create our own custom modifier actually inside of this smart contract so that only certain people can call this add person function. All right. So what I'm going to do is basically, make this smart contract have an owner or like an admin. And we're going to say that only the owner can call this add person function, and any other account connected to the network, whenever they try to, add a person, they won't be able to. And that'll show you how we can add an extra modifier to this function to make that happen. Basically, we'll just add a modifier that says that only the owner of this smart contract can do that. So first, we need to, well, actually, that'll just look like this. We'll say only owner. That's what the modifier will look like. Now, this only owner modifier doesn't exist yet, so let's go ahead and create it. All right, so we'll do that like this. First, we need to keep track of an owner. We'll say the owner is, address. I'm not sure if we talked about this in the data types video, but, an address is a data type inside of Solidity. Like an address that's on the network, an account. So this will be the address. We're just going to declare it here. We're not going to set it just yet. We can set it like this. We can do it inside the constructor. Well, actually, not to do that just yet. So that would be the owner. We basically just create a modifier like this. We say modifier. Say only owner. It's like a function. And what we'll do inside of here is write the logic that makes sure that, whoever's, calling the smart contract is the owner. So that's what we're defining here. Only owner and only owner. So how do we do that? How do we say the person who's calling this function is the owner of this smart contract? Well, we're going to compare it to this owner right here. But how do we know who's calling the function? Well, Solidity has a global keyword called MSG, which basically stands for the function metadata that's passed in. And we're not actually going to pass in any metadata here. It's going to be implied. So basically, we have access to msg.sender. And this is basically a special thing inside of Solidity that tells us the account, its address, who called the function. And basically, we can just say, is this person the owner? We can just, compare equality of the person who's calling the function with this owner that we're going to store here in a second. All right. And if they're not, we actually want to throw an error. All right. So this is going to show you another concept in Solidity about error handling. So we can throw an error in Solidity, like, I think earlier we had some errors happen, like here's an error. We actually want to trigger an error if this person, is not the owner. We want to revert the transaction. And we can do that like this. We say require, msg.sender is equal to the owner. So basically anything inside of this require, if it evaluates to true, then this passes. If it evaluates to false, then this will throw an error. We basically are saying require that whatever you put inside of here is true. All right. And then after this, we can basically just do this. All right. And now our only owner modifier is complete. So basically now we have this modifier that's defined here, and we add it here. And basically we say if the person who is calling this function is the owner, then we can actually run this function, and if they're not, we're going to create a failure. We're going to revert the transaction, and also whoever's doing this, whatever, like this code won't run, so they won't pay this gas fee. All right, so now we need to set the owner, and I'm just going to do that inside of constructor. We'll use msg.sender as well. Say function constructor, and we'll just open this curly braces, and we'll say owner equals to msg.sender. Sorry, I don't need the function keyword here. And we also need to make this public. All right. So I'll save that. So whenever you deploy the smart contract, like this constructor gets run, and the msg.sender is actually the account that deploys the smart contract, and they're going to get set to this owner state variable, right? It's address owner. And basically, that same address is the only person that's going to be able to call this add person function. All right, and if they, this code will run, and we'll be able to add a person. And if we switch accounts to some other account over here, then it won't work. So let's just try that. I deploy this. We will, deploy with this account. So let's change to that account. We'll add the person. Actually, I don't know if it deployed that account or not. Let's try it again. So make sure on the first account, we'll deploy. All right. We'll add a person. We'll say DAP University. We'll add the person. All right, let's see here. All right, it worked. The people count is 1. Now we'll say, Joe Blow, and we'll change accounts to this one. And we'll try to call it again. We'll add a person. And we see it has failed, and the people count has not changed at all. So it worked. So we've kept track of the owner, and we say only the owner can do it. Now while we're here, I'm going to show you a little code formatting that I like to do sometimes. This is getting kind of long, and sometimes, if you're like me and you have a text editor with a whole bunch of panes open, I like to keep my columns kind of short sometimes, especially with Solidity. And it kind of makes it easier to maintain these functions when the arguments start getting long and you're using get and things like that. Sometimes I will just break these up like this. All right, and then I'll actually put the modifiers. If you have a bunch of modifiers, sometimes this makes it easier to read. And also when I'm writing my own Solidity source code, I only use 2 spaces. I don't use 4. But yeah, that's sometimes how I'll break these functions up. So I can see the function name and then the arguments. Then I can see the modifiers, and then I can actually see the code that gets executed inside here. And it can make your smart contract kind of long, but it can be, sometimes this will catch you. If you have too many, if you have 3 visibility and modifiers on here, sometimes it can be kind of tricky. So I like doing this. All right, so next, I'm going to show you how to work with time in Solidity, okay? So what we can do is basically compare time in Solidity. And instead of this saying only owner can do this, let's say that you can only call this function if a certain time has passed. So let's pretend like, this is a contract that is only open at a certain time. So we'll say instead of only owner, we'll say only while open. Only while open. All right, and this opening state is going to be determined by a time. So once we've passed a certain time in history in the future, then we'll let you call this function. If it's before that, we won't do it. So that's really useful if like you're building a crowd sale or something like that has an opening time, like an ICO smart contract, and you say, hey, we can only let you contribute Ether like after, the first of the month. Well, you just figure out what time that is and say, hey, if you make a contribution before then, we'll throw an error. So I'll say only while open, all right? And instead of requiring that MSG, that sender is the owner, right? We're actually gonna just take this out. We're going to say, we're going to make sure that the current time is in the future, beyond a certain opening time. So let's do uint 256 opening time. All right. So how do we do this? Well, we need to set this opening time somehow. All right. So the opening time is actually expressed in seconds, inside Solidity, or these timestamps are expressed in seconds inside Solidity. And seconds of what? Well, it's epoch time, which if you're not familiar with that, it's a concept in computer science that's like the epoch is a specific time. I can't remember the actual date. It's like a date in the 60s or 70s or something like that. And basically, we just add seconds since that point in time in history. So this is the current epoch timestamp is this many seconds since the epoch time. And I guess there's probably a link here where you can read more about that. Yeah, the Unix epoch clock. Yeah, I'm sure you can get on Wikipedia and figure all that out. But basically, this is the current epoch time and it's changing. So we use these seconds values. So this is like the current, epoch timestamp. We'll say this. All right, so this is how we could set this. And it's, uint 256 is going to store this big number of seconds since that timestamp. And that's going to be our opening time. And so how do we compare that to now? So how do you get now in Solidity? Well, there's no perfect way to do it, but the best way is to get the current block's timestamp. All right, so how do we do that? Well, just like MSG, there's a global variable in Solidity called block dot. And we can say block.timestamp. All right, and we can say, is the block.timestamp, is it greater than or equal to the opening time? All right. So basically, if it's after the opening time, we're going to let you call this function. And if it's not, then we won't. All right, so let's give this a try. I'm going to update this timestamp. Let's refresh it. Let's see. This is the current one. I'll paste this in here. So 15. I'm going to add 60 seconds, so a minute. So I'm going to deploy this, and it will be... it shouldn't work right now, so we can try to call add person. We'll try to add DAP University. Okay, we'll add person, and we'll see that it reverted. Okay. And now we can check the timestamp. We're not there yet, so I'll just pause the video and wait for this to pass 75. I think that's the actual time. Yeah, 75. All right. I'll pause the video. Pause the video, giving us plenty of time. We're past the timestamp. You can see it's 793, and we're at 775. So let's deploy it again. Or actually, let's not deploy it again. Let's just do Joe below, add a person, and it worked. So that's how you can use time in Solidity. You can get the current time and set a time value with seconds. And so that's what I'm going to call today, guys. I hope you all like this video. Let me know how you're enjoying these Solidity videos. Let me know if I've missed anything or if there's something you want to learn, or if you're just not liking them, that's okay too. Just let me know down in the comment section below. And also be sure to subscribe to the channel if you haven't already, and click the like button down below, because that really helps these videos get found so that more people can learn how to build blockchain technology. And it also helps keep me making these videos for you all. All right, until next time. Thanks for watching DAP University.